Imagine your Rust API suddenly receives 1 lakh requests per second. Your server does not crash, it just becomes slow and then dies. The problem usually is not CPU, it's uncontrolled concurrency. Today we are going to learn a production architecture pattern in Async Rust which prevent this exact same issue by using rate limiting using Tokio Semaphore. So, most async beginners assume async is equal to infinite concurrency, but that's dangerous. Imagine this code where we have uh, asynchronous handler which waits for 2 seconds and we are spawning that asynchronous function in our main.rs. So, what happens here? We spawn 1000 tasks instantly. That means 1000 DB connections, 1000 API calls, 1000 memory allocations, and suddenly your system is overloaded. Real production systems never allow unlimited concurrency. They limit how many tasks can run at once. The most common solution in async Rust is semaphore-based rate limiting. Think of it like a parking lot. If the parking lot has a 5 spaces, only 5 cars can enter. Everyone else must wait. Tokyo gives us exactly this perimeter by using Tokyo Sync Semaphore. So let's implement that rate limiting pattern in our code. Uh, so for that, we will first create a variable and we'll use arc and semaphore of Tokyo Sync and we'll use semaphore here and new and parameters like how many requests you want at a time. For for this example, we're going to be passing 3. Okay, then instead of 1000 of spawning, we'll for starters we'll just do 0 to 10. Uh, we'll look to 0 to 10 for this example. So let's do that. Acquire clone. Yeah, and we'll avoid it because it's asynchronous. So uh, then we'll our spawn our asynchronous handler. So let's spawn that. It's giving an error. Okay. Yeah, I just had to add a semicolon. Now we'll wait for 10 seconds. Okay, and now we'll run our program. Now that we have implemented our Tokyo semaphore rate limiting, so we are going to run a program. So let's run our program. So as you can see, it first starts with first 3 requests, then it finishes, and then it goes on to another 3 requests, and so on. So now the important line is right here, which is permit semaphore clone and acquire owned and unwrapped. So what this line actually does is it does 2 things. First is it waits until a slot is available. Second is locks that slot. Only 3 tasks can run concurrently. When a task finishes, the permit is dropped and freeing space for the next task. This creates automatic backpressure. This pattern is used everywhere. For example, API gateways which limit requests per service, and then database pools which limit concurrent queries, then web crawlers which limit parallel HTTP calls, then external APIs which avoid rate limiting bands. Without this pattern, async system collapse under load. This is more than a rate limiting. It's about controlling concurrency boundaries. Good async architecture always defines task limits, I/O limits, memory limits. Semaphore become a core building block for that. Async Rust is not just about async await, it's about architecting concurrency safely. In this video, we have learned how to implement uh, semaphore-based rate limiting of Tokio by using Tokio. And we'll continue such video like this in our uh, Rust design pattern architecture series. So yeah, that's it for this video. Thank you.